so I've now taught that lesson with the Year 9 group. Few things that were apparent with that. First thing, the checking the learning from the previous lesson was key. I think just to reinforce that with the kids so they understood in their heads, they knew what energy was, they know what can happen to energy, and reinforcing that before they go on to the key learning of the lesson. And it really helped me because obviously with a split class I didn't teach them the first lesson, so I was able to check that they understood those terms, and they were using words like transfer and dissipation and things like that, so that was really useful to check the previous learning. As I thought it was quite useful using a different context and using Newton's cradle as well to see if they could apply previous learning to a slightly different situation. The second task was this one here. Again, this was a checking of learning. Do they understand the energy transformations that different devices do, and can they identify input energy from wasted and useful output energy? That was really quick. So obviously they did do a lot of that last lesson, but again, if they can't do that, they're not going to understand efficiency. So I just reinforced that. That was less than, probably about 2 minutes, so they could do this quickly. Very useful check. One issue which it did address was people's understanding of chemical energy in terms of the coal in the steam engine. Most of them are happy with that, the hairdryer and the TV, but obviously the chemical energy and thinking about where that energy is stored, that was quite useful just to talk about that. The third part of the lesson, or third part of the timeline, was the teaching efficiency, but trying to get them to come up with their own formula or equation to work out efficiency. This took longer than I thought. I think some of the kids in this class are a bit thrown when they're given a challenge like that. We have to work something out for themselves. So some will just not take about 5 minutes before they actually read the question properly. Some will just sit there thinking I can't do it. But eventually, through them discussing and helping each other out, and I think stressing the words like proportion. So in maths, for example, what does proportion mean? How can we express something as a proportion? And when they came out with fractions and percentages and things like that, then they could progress with the task. So if you remember, that was the task there. So I gave them the definition of efficiency, and they had to come up with their own formula to calculate efficiency. So that did take longer. What was useful is that some of the pupils were coming out with efficiencies of over 100%, so we could go back to a key learning point and said, so can a device be over 100% efficient? So what have you actually done wrong there with your calculation? Task 4, once they'd come up with efficiency, I'd reinforce that by showing them the equation and got them to write it in their books, making sure they could use it. Task 4 was actually simply plugging numbers in. So this is exam technique. They were fine with that, so they looked at the different examples on the board, they identified the useful output energy, and then divided that by the total energy in. And by doing it a few times, it did help them to understand that they can express it as a percentage or as a decimal. Either is fine. Again, low level stuff, but exam technique, and they could do that very quickly. So that was quite a quick task. As I said, the main thing that took time in this lesson was getting them to construct the formula in the first place. And then on to the application. Now, we had about 15-20 minutes left at this point. So the last 15 minutes was mainly me demoing the water wheels and them starting to think about what questions they needed answering for next lesson. So I did in the end take 2 lessons. So the following lesson, they all had different water wheels, and they did the investigation over the lesson, and the last 15-20 minutes we could then look at the answers and think about where the inefficiencies were and how we could overcome those problems. So talking about friction and things like that. What did help was it could identify those kids who are quite happy to work with small numbers, because the efficiencies of these water wheels were pretty pathetic. So, and they were using small numbers, obviously. So it helped to show how they could structure their thinking through a problem. And as I said, finally was just that table. So I just put the table on the board. Right, so based on what you've learned, we know they're inefficient. Can we think of why they were inefficient? And can they come up with ways to reduce the problem?